All right, now I want to talk about, in the next set of slides, I want to talk about cryptography. In particular, I want you to understand what it means to encrypt and decrypt a message, right? So the problem that we're starting with is the following. You want to send a message that you want an attacker or nobody able to read except for the recipient of it. So now the way we want to do this, and then the principles here are very similar to the ones that we have established with hashing, is that it should be very easy to decrypt. Actually, it should be very easy to encrypt a message. It should also be very easy to decrypt a message if you have the rights to do it. And it should be extremely hard to decrypt the message if you don't have the rights to do it. Okay, so that's basically the mechanism that we have here in mind. So now we do some formalism here, because effectively this is something which is a piece of math. And in fact, for those of you who are curious in it, what this really uses is number theory. And I'll get to the examples of how this works in particular in a minute. But just keep in mind that all of this is based on number theory. So that is basically the relation of number theory describes the relation of numbers and the special features of numbers such as prime numbers and the like. So now we have to have some formalism. We call the message that we want to send M. And now the encryption that we're interested in is so-called public-private key encryption. So how this works is there is a message, there's a public key, and there's a private key. To use for the public key, we use big P, and for the private key, we use S for secure. And then we have something called a cipher text, and we call this C. Now what the cipher text essentially is a modification of the message with the private key. So here's how this works. We encode the message by basically creating an encoding of the message using the public key, and then we get something out of it which is P of M. And then we decode the message with so we take the cipher and we apply to it the private key. And then so the output is P of M, so there's a public message if you want, there's some public information, and then you have the private, the secure output of a cipher. And I said something before the wrong way, so I apologize for that. You basically use the cipher as a combination of, no, actually it's still correct. So deciphering works by applying the private key to the cipher. Okay. So let's just visualize this, because this is, I don't want you to know all the details, but I want you to visualize what's going on. So Alice wants to send Bob money, and they don't want Charles, an attacker, to be able to see it. So what she does, therefore, is she takes a message, right? And then she wants to send the message over to Bob. And what she needs to do is she needs to apply the key. So okay, so blah, blah, blah. Now, how would this work? Now, the simplest way to do a cryptography is that she applies a key which is so-called symmetric key, which means that she has a key and the recipient has exactly the same key, right? So, the way to think about it is she takes the message, she applies the key, she sends the message over to Bob, and Bob has the key, the same key, and can therefore decipher it. You have probably done, kids do this, for instance. They take a text in the alphabet and they send a message, and all that they do is they take, they change the way the numbers work, right? So the letters work. So for every A, use a B, for every B, use a C, and so on and so forth. Or you have some other form of a mapping between letters that you want to use and going back for it. So the key is essentially exactly what the other person has done. So let me briefly explain how a symmetric cipher would work. So you see here on the side of the screen, you see the letters of the alphabet, and you can see that, we just numbered them, right? So A is 0, B is 1, C is 2, and so on and so forth until Z is 20. And a symbol encoding, the kind of thing that you probably learned as a kid, is you just take the number that you assign to a letter and you add 3 to it. And we have this moduli 26 there. So just you see how this works means that, so you take the number 0 and you add 3. So A becomes 3, B becomes 4, C becomes 5. W would then become 25. Well, but in order to make sure that you still use the numbers from 0 to 25 only, you then have to restart at 0, and this is what the mod operation does, right? So this is the remainder of it. So you take, formally what this means is you take 25 plus, 23, this would be x, plus 3 would be 26. That is larger than 25, so you divide by 25, so the remainder is 0. There we have it. So you have, x is 0 and so on and so forth. And that gives you then the, the corresponding number as a cipher. So as an example, if you want to take the word management, the letter M refers to number 12, the A refers to 0, so you have the management converted to numbers 12, 0, 13, and so on and so forth. And then the cipher of this would just be the number assigned to the, to the shifted one. So management, the M is no longer 12, it's now 15, and so on and so forth. And so what happens is that both parties, so Bob and Sue, both agree on the cipher. And so what they do, the simple thing that they do is that Bob receives the message, and the attacker, of course, looks at this, that he or she doesn't understand how this is coming about, but Bob uses the same cipher as the one that Sue used in order to encode the message, and he can then decrypt. And that's basically how symmetric these letters. Now that is symmetric, and that's something that can work. But it is something which is kind of problematic, right? Because the problem is that, both of these parties need to have the same key, and that implies that they actually have to have a trusted relationship with one another, right? So now, so what you want to avoid is that, and when you want to do things anonymously, this becomes very difficult because you cannot differentiate the attacker from the valid recipient. So symmetric is not what you want. So the formal part here, though, of these keys is that the public key is the same as the private key. Now, what we're mostly interested in, and this is how the world really works, is with asymmetric encryption. So where Bob has a public key and a private key, okay? And so he has two different keys to encrypt a message. Now, what Alice has is she also has the public key, and so what she does is she takes the message and she signs the message with a public key. Now the attacker may even know what the public key is, and he may, but by just seeing the message in the public key, he will not have the ability to invert the message. The only way how the message can be decoded is by having the private key. So that's essentially the idea. So Sue takes the public key, which, Bob can actually what Bob can do is she can just post the public key on the website. Sue takes that public key, signs the message, applies the key, and then sends the message. And then what Bob has to do is he takes the message and decodes it with a private key. That's basically the mechanism that we have in mind here.